you for all turning up to this training session on the St James sound system. And we're going to be covering today in terms of the workplace health and safety requirements, an overview of all the parts of the system and how they trace together, and also do a little bit of troubleshooting. So I hope you're going to enjoy it and get something out of it. I'm sure you've all got different experiences of this sort of thing. And my objective here is to facilitate vocational training. So I'm supposed to shut up at various points, encouraging you all to talk as much as you possibly can. So I will jump out in a minute, but we've got everyone here. That's good. If you're all interested, there is a learner's code of conduct. Beautiful, just as a common sense sort of thing that's set up by the quality education which we're using as part of our TAFE course here. Thank you. So if you have any questions about how I'm behaving, how you're behaving, there it is. Wonderful. You all know the facilities here, but just to remind you, the escape route is through that door over there, which has a panic push bar. And if we move into this room over here, there's only one exit, so just be mindful of that, and you can escape. And again, push bar if you need to into the backyard. The responsible person here is the Reverend Susie Ray, and there is a reporting incident system that is over on the wall, sort of near the where everyone's eating over there, near the toilets. You can grab a form there if there are any incidents that you need to report on, including myself. Thank you. So, what did I just say?
You told us where the emergency exits were, we told us about the anomalous behaviour.
I didn't see that.
The incident report and who is responsible.
That's it, good. And we've got a learner's code of conduct. Everyone's here, the exits, Susie's in charge. Lovely. So we've checked in on what we're doing. Grace is going to be recording, and I'm loosely keeping time over here. I think we started about 3 or 4 minutes ago. So. Excellent. All right. Now, I'm going to be using this for most of our demonstration because I kind of figure it's a bit of an overkill over there. Can everyone see that nicely? Enough? So, I've got 3 objects on this screen. Does anyone know what they are? Maybe the first one. What's the first one? We don't see them too often. It's got a cable leading to it, which gives a bit of a hint.
Is it
you
like...
might see them in a switchboard. Anyone heard
Fuse?
of RCD?
No.
RCD?
Remote control device?
Oh, well, it kind of is in a way. It's certainly remote. It's called a residual current device. We're dealing, this is obviously an occupational workplace health and safety issue. We're dealing with things that are powered all the time. And in the sound system, naturally, everything's powered. Can you think of some of the ways the sound system is powered? Some of the objects are powered. Speakers, yeah. Anything else?
Everything's plugged in.
Everything's plugged in, yeah. Does everything have power running to it?
The boards themselves, the amplifiers, all that does power go into it.
Yep, the instruments. Instruments are interesting. What do the instruments? Well, we'll talk a little bit about that later, but they're actually the direct input boxes are actually powered by this sound desk here. So there's power even running through, as you can see, this is all plugged in through these cables here. These are all the inputs. But there is power going through some of these lines called phantom power, and that runs through 48 volts. It's quite a low amount of ampere running through it, only 10 milliamps, but running through the cable all along there, back into those little boxes you see up front. We'll talk about that in a minute. That's phantom power, exactly. Yeah. So phantom power is running and powering the little boxes that convert high impedance signals into low impedance signals. We'll talk about that. Anyway, there's power running right through this, so we have to be mindful of how we protect ourselves if there's, for instance, what happens if someone pours some coffee on the machine? What happens? We get some fire and sparks and that sort of thing, because the nipples join together. So this device is designed to protect us, and there are these installed in every commercial building. I think now, just about every household in the nation, residual current devices, and they detect when there's a fluctuation in the alternating current between the neutral lines. And if there is a fluctuation, they pay out 40 milliseconds. If you ever find a problem in the system from a power perspective, the last point, but the definite point, is this residual current device. But just bear in mind it's sitting there in the switchboard in the office, and if it's activated, and it has activated from time to time, for instance on the air conditioners when they run too hot, that can be a source of problem, but also it's a way of mitigating the risk of using electrics. It shuts down everything on that circuit. And this is all running from 2 circuits. I'll go through that now. Anyway, there is some protection, but we do have to watch out for having drinks and all that sort of stuff around electrical equipment anyway, so we try to keep all food and drinks away. What's the second thing? Can you see what that is? It looks a little bit more familiar. It is definitely an app.
Is it like a decibel tracker?
That's exactly what it is, and this is actually from a few weeks ago when Gina was doing sound setup. And I thought it was a really good snap because it shows the decibels on average and the max that was happening at that point in time. And it says that it's like being inside a car with a stereo going. This is actually really good reading, and if we get max peaks at about 90 dB, that's probably reasonable. That's okay. But the average shouldn't be anywhere near that. It should be around about the 80 mark in a building, and Jenny does a great job of balancing that out. There's always a few problems, but it's worth having this on anyone can have it on their phone. Has anyone had any experience using that? Anyone had any experience with ringing ears?
And the number by which you discover a new protection?
I think for a long, if you listen at 90 dB for more than 8 hours, you will experience hearing loss. So, and why would that be important in this area?
Because we have a lot of sound happening and a lot of people around the area, and
A lot of people, we have a responsibility to everyone in this room to make sure we don't blast them. So it's not just about ourselves, it's about everyone in the room. It does carry some responsibility. Anyway, it's one way of sorting that out. The numbers aren't always exact, you know. You can run this sort of thing, and also the microphones in those units are not 100% accurate, so with a bit of flexibility. But if there's a couple of basic rules on them, can you think of a rule that might be useful when we're dealing with sound? Yeah, but what sort of a certain amount? How would you gauge that?
It's not like ringing ear loud. So like you said, if it's below 80 decibels, then that.
On average, yeah.
On average.
And what could be a practical test for that? I mean, what do we do in the church?
Look at how people are
When
responding.
we're in worship, what do we do? Yeah. Now, have you ever been to church where you can't hear yourself sing?
ha ha ha, yep.
What's it like?
Painful.
Why is it painful? Yeah, it's too loud, definitely too loud. So that's the big test, I think. If you can hear yourself sing at the back here, that's a problem. Anyways, that's the second type of workplace health and safety issue. What's the third one? Do you know what
Tripping cable.
That's a tripping cable thing. What have I done here? I've taped it down. Now this is a bit makeshift, but I'm required under the workplace health and safety requirements of this course and training and the standards for RTOs 2015 to make sure this is a safe environment. So I've used gaffer tape to tape down that as a barrier so we don't trip over the cable on that floor. It is actually a problem in this church. You have to do it at some point. Really should be under but otherwise it's actually a reasonably safe setup. So tripping hazards are always a problem with using this church. I hope I haven't bored you too much on that, but do you have any questions or would you like to discuss anything further about sound or power or tripping hazards? No questions? No thoughts? Good. All right. I'm going to briefly jump to a metaphor. A metaphor is where you take an idea from one realm and stick it into another. And so I'm using the idea of a river as kind of like sound. The river is like sound, the river is sound. The river source is like a sound source. And so my example here is actually in a kind of biblical area, really, isn't it? It's up in the mountains of southeast Turkey. There's the beginnings of very, very high mountains, which are the beginnings of sort of like this Tigris-Euphrates system. From the mountains, water's collected in the gorges, and the gorges end up turning eventually into the plains across the flat areas here, and they spread out. And then, but somehow managed to work themselves into one mouth and then out into the Persian Gulf. This is a river system, the Tigris-Euphrates system. Sort of helpful. It stretches a little bit. We'll see that later on. But my analogy stretches to the sound system in this way. The mountaintops are kind of like the musical instruments. The gorges from the mountaintops that are coming down are kind of like these channels, the different types of instruments that are going on and how we control them. The plains is kind of like a place where those two, the gorges, the streams coming from there, kind of merge out into the flatlands and they go off into different directions. And I'll explain that a little bit because there's two types of outputs. And the last one is the meating of the mouth, the output, which is the main master going into the speaker system. Does anyone have any other ideas of a metaphor for a sound system? That's one I came up with, but it's not perfect. Anyone got any others? Like a source destination idea? Like life is like a journey. So we take life as a time span and then turn it into a journey, which is a source destination. Anyone got any other ideas like that? What's it sound like?
Flowchart.
Oh yeah, that's a good one. It's exactly, yeah, totally. Why? Flowchart's a great idea. What causes that to split off? You've got a process.
Yeah. Starting point, process, or notice,
Options. Yeah. And that's kind of what's going on here. There are lots of options here because there's lots of dials making it quite daunting and how they relate to all the different parts. That's a great example. I wish I'd have thought of that. Maybe that would have been a better one. Anyone else got any other ideas?
I'm thinking like train tracks.
That's a good one. Train tracks are a great idea. Yeah. Because you can split off into different sections, but you end up all at one station or one termination. Yeah, that's a really good example. Because that's got, if they end up at a speaker somehow, then that kind of is a line, isn't it? Really, at the end of the day. But is it the main line or is it just a little line off to the side? Really good example. Well, that'll do for now. But that's the idea. Try and think of things that might make sense to you when you're looking at a sound system. For me, a chart like this makes a lot of sense. But for some people that will make absolutely no sense. You know what I mean? So what I'd really like to do right now is I'll give you one of these each because some people like that touch and feel when they're learning. So this is a summary of the system. And what can we see here? Oh, Gracie, do you want me to look at that? What can we see here? We've got, you see the flow here, a bit like a river? What's at the start of the river? The musical instruments, that's right. It's a little bit different here. We've got, can you see what's connected to the drum kit?
Various buttons.
That's all, they're microphones, aren't they? We don't have microphones in our drum kit, which I really like. Because we can control the drum kit, control something we'll talk about later. Everything's plugged in more or less like a guitar. There's also some microphones there. There's one here for display. Microphone here. There's some guitars at the front. We're going to play with them a little bit later. What else do we see?
Feedback device.
Well, they're actually, that's the DI box I was talking about, direct input box. The thing that's powered by fan and power, right? This sort of thing we don't have in the system. And the keyboard, we're not using the direct inputs for that particular purpose, but we actually have them plugged in here. There's one particular instrument return here. There's one channel being used. I think it's from the CD player, which no one ever turns on. And what else do we have? Got the desk. What's the desk doing?
It's the desk.
Yeah, that's it.
Controls the volume.
And it that's exactly what it does. It controls the volume to. What does it control the volume to?
To all the various devices that it's connected to.
Yeah, that's right. So it's controlling it to of those devices. They're the inputs or the sources, and they're going out to speakers. Exactly. Gives you a better flow. I think it kind of works a lot better than you're welcome to have one of these because they give all the details of what's going on in the circuit. They're kind of more confusing at this point in time. I might leave them for later, and if you want to pick one up, you'll really get all the details of what's happening on the desk and how they connect together. And the flow chart, in fact, this looks a lot more like a flow chart, doesn't it? We'll leave that there. And there it is on the screen. Perhaps to put it in a more tangible way, these are the sources. We have vocals for a microphone. It's the microphone. one of the ones we use. It's got 3 little pins there. It's called an XLR input. It's actually not producing much. How would this get electrical currents into the desk, do you think? Wire cables, yeah. What turns sound into something that's electronic? 'Cause everything's electronic. This is for cables, so it must be electronic. How do you think it becomes that? Got any ideas on what it uses?
I know it uses a diaphragm to.
Yeah, it does. What does the diaphragm
Transmit
connect
sound.
to? What's the main thing it uses to convert sound?
We did this in physics in year 12, and it's been 2 years since then.
There's sound waves, isn't there? It's
Yeah.
using electromagnetism, and you probably know more about
Oh,
that
yeah,
than I
of course.
do. The earlier microphones actually had ribbons that would sort of pick up sound, and then that would connect to inducers and then through the microphone. But these days they use magnets. So that's what's happening here. And it actually doesn't have, how much electricity would get produced by that? Not very much at all, actually. It's just sound waves connected to an electromagnet. It's not very powerful at all. There are some microphones that are, but this one is because it's actually being amplified through an electronic system. But these are called dynamic microphones, and they don't give out much output, which is good. So they're called low impedance instruments. The rest we have some guitars, the electric drums, and keyboards. They're all, because they're self-powered, they have a very high impedance. They're sending a lot of signal into the line. And so that's why most of them, except for microphones, get put through this little box here called a direct input box, which is powered by this desk from phantom power. And that enables the reduction of the signal from high to low impedance. It's that one just there. Can you see it on your chart there? Just that one there, and that one.
So you don't need it for a microphone.
You don't need it for a microphone. That's exactly right. It's all for the high impedance signals, and then it goes through a thing called a snake. Can you imagine why it's a snake?
Because it's swollen thin.
Yeah, it's a bit like Medusa. It's got lots of heads at the end of it. But it's not a very big snake. It's a typical snake, really. And yeah, that's what's going right across the building, along with the Ethernet cables and all that sort of thing. So that is our first session. That is basically the source of the musical instruments. It covers off some of the safety requirements and that sort of thing. Anyone got any questions at this point? No, all good? Why don't we just take a moment just to chill before we go on to the next session? Is that all right?